So I'm going to tell you guys a story from my childhood when I was a little bit younger than you guys. And I trick-or-treated up until the 13th grade. I don't know if you guys are still doing that.
The 13th grade.
13th? Yeah, that's what we called it. But how many of you guys still trick-or-treat? You do? Good for you. This is the best excuse for younger siblings to take some trick-or-treating. And when you're done, you say, I'm going to take my candy tax now. My candy tax is half of whatever you gather with my supervision. Right? Don't you guys take your little kid siblings trick-or-treating? No? Okay. Well, I'm going to tell you a cautionary tale because the most important thing about this Halloween is that you guys have a safe Halloween. Once upon a time, when Mr. Darger was in 7th grade, Mr. Darger was trick-or-treating in his neighborhood. And he found himself on a night, it was blustery and stormy, and there was lightning everywhere. Lightning everywhere, and rain. And so I sought shelter in an old abandoned mansion. Ooh. How many stories start off like that? Are you scared yet?
No.
Oh, okay, well, let's see. So there was a lot of lightning, and does anybody know what lightning is?
Plasma.
Plasma, okay. So they can make plasma. It's electrons, it's electricity, right? So we're going to see if we can make some lightning, and sort of, you guys aren't scared yet. Maybe if we make some lightning, we'll scare you guys. So I have here what's called a Tulsa coil. And it's sort of an interesting thing. It looks like a drill, right? And when I turn it on, what it's going to do is it's going to generate a high frequency, high voltage electrical field. And when I touch it to something, now we've been learning a lot about bonds in here, right? What kind of bonds conduct electricity? Are they the covalent? No. Ionic too. And also what other kind? Metallic. So if I was to say, touch my Tesla coil to this is made out of plastic. And plastic has covalent bonds. Do you think this is going to conduct electricity? No. If I put this near it, look, nothing happens. But if I was to put it near something with metallic bonds, like for example this, you guys see the lightning coming off of there? So the way lightning works is it does what's called ionizing particles that are in our atmosphere. It's when there's a big difference in potential between the sky and the ground, and the potential jumps across and goes down to the ground. And on its way, it ionizes atoms that are in the air. And that's what's going on here. When you see those purple sparks, it's ions forming. But you've got to remember, ionic bonds happen when you have two things with charges. And they are attracted to each other because positive and negative charges attract towards each other. How many volunteers today? Okay, so I saw your hand go up right away, and you're going to help me out with this. Give me 1 second, okay? So, we said metallic bonds attract, like this. And this is a big piece of copper. And Rebecca, do you want to hold on to this for me? Come here. Only hold the plastic, okay? Thank you. And yeah, you are going to have to wear goggles every time you come up. So hold this, grab it by the handle, and then I want you to touch it to the metal. And so this is copper. What kind of bonds are going to be between those copper atoms? Covalent? Copper is a what? Is copper a metal or a non-metal?
Metal.
It's a metal. So if you have two metal atoms and they make a bond, a metal and a metal make what? Metallic bond. So does that conduct electricity? Yes. Okay, show me how it conducts electricity. Tie on your glasses or over there? Yep, we're close to it. You guys see those ions being formed? As the air ionizes, the heat generated a coil of sparks. Okay, stay there. Hold on to it. Another interesting thing about electricity is what can happen when we apply it to something, say, like a light bulb. So go ahead and put it near the end of this. Whoa, she didn't even touch it. You guys saw what happened. Whoa.
Okay.
Do it again. Don't touch it though. Okay, get closer, get closer, get closer,
move your hand.
Closer, and you said move my hand?
Yeah,
alright, move my hand over here. Yeah, fluorescent light. So these have, and does anybody know what kind of atoms are inside a fluorescent light? Well, there's what? Positive atoms? Maybe there's some ions. They're gases that when they're excited, so for example, neon and argon and fluorine, and some other things that are in there, when they're excited by electrical charges, they give off light like that. So put it near it again. And so as the electricity passes from Rebecca's Tesla coil in here, and then it actually gets grounded by me, and that's why it's dark from here over, it lights up. And here, Rebecca, I'm going to trade with you. I want you to hold on to this now. And I'm going to grab this. Do you think that's a good idea?
No.
All right, well,
Yeah.
anyway. And then, Rebecca, here, take my hand. Hold on to it. Wait, hold on to the end of that. This is strange. It's not working. You don't conduct electricity. Hold it away from your body. Hold it away from your body. There we go. And then turn it out towards Miss Malin. Weird. Now put it towards your body. I want to see why this happens. Interesting. I wonder why it wasn't working before. Oh, it's because you weren't touching the end. Okay. And again, we can see that when I'm touching it, lights up. And then when I'm touching her, put it away from your body again, it lights up. So what's the electricity doing? It's passing from me to Rebecca to the light tube. I'll take this. And that's sort of interesting, isn't it? You can light up a light bulb without even connecting it to any wires, because we conduct electricity, because we have a lot of ionic bonds in us. The human body is mostly salt water, right? Whether or not you know that, it's mostly salt water. And the sodium chloride, Darren, that's in salt, the sodium and chlorine, they make an ionic bond or a covalent bond. Sodium's a metal, chlorine's a non-metal, ionic. And so the ionically bonded salt that's inside the water that makes up us conducts electricity. And that's how I'm able to light up this fluorescent bulb without doing anything else. Okay, I'm going to stay there. I've got one more thing for you. And we're ready to go. Here we go. I'm going to ask you to hold this, and it's really important that you hold it by the glass, okay? Hold it by the glass. And we're going to see what happens here. Don't be nervous. It's not going to hurt you, but it will get warm. And I want you to rotate around so that they can see what I'm talking about. You guys see the sparks going up from here, and it goes up the coil. There's some tungsten wires stretched between two poles. And the electrons want to go from here up through the metal, and then they jump off, and ooh, I can feel it. I just shocked you a little bit, sorry. And you can see the sparks jumping to her hand, but it's insulated by the glass, because glass atoms are silicon and oxygen. And guys, silicon and oxygen are what glass is made out of. And silicon is a nonmetal, and oxygen is a nonmetal. So what kind of bond is glass? Two nonmetals. What kind of bond? Covalent. If it was two metals, it would be, and you'd be shocked. If you were holding this piece here, you want to hold a piece of copper and then you do it? No, you don't, because metallic bonds conduct electricity. All right, thank you very much, Rebecca. Good job, Rebecca. Way to be brave. That one thing, you have to be brave to do that one. I'm crazy, and I might, shock you. So, anyway, it was a dark and lightning-y night. Lightning-y is what I call it when it's lightning out. And I stepped inside this old mansion because I wanted to get away from the storm. But it was dark in there. And when it was dark, I was like, how can I use my 7th grade knowledge of chemistry to illuminate the interior of this mansion? Does anybody know how you can make a really bright light using chemistry?
Firewood.
Not any firewood. I don't carry that. No? But what I do carry is something called magnesium. And is magnesium a metal or a non-metal? No. It's a metal. And so I could take some magnesium, and I'm going to ask for another volunteer now. And Tequila, go ahead and come on up. And Tequila, you need those goggles. Where'd those goggles go? And Tequila, you're going to hold on real tight to this, please. Real tight. Just squeeze them together like a pair of scissors. And you're going to hold it over this. And magnesium metal has some unique properties. Magnesium metal is one of the things that we use to make fireworks. Does anybody see my blowtorch? Oh, it's right here. Magnesium metal is one of the things that we use to make fireworks. And it gives off a really bright white light. Now, it's so bright. You guys have seen this with Miss Morrow?
Yeah.
Okay. Well, some people have it, some people haven't. When magnesium burns, it gives off a bright, bright, bright white light. So what are you not supposed to do? You're not supposed to stare at it. Now, it's not going to kill you. If it was going to kill you, I wouldn't do it, because some of you guys are a little bit less than brilliant. And when I say don't look at it, you're like, oh, I'm going to stare at it. So don't do that. This is your warning. It's not going to kill you, but your eyes will hurt. so don't do it, okay? You'll see it plenty if you look to the side. So what I did to illuminate the interior of the mansion is I lit it, and hold it over the metal, please. So I lit it, and it burned a brilliant white light and lit up the interior of that mansion. And what did I see? But the crazy, smiling visage of somebody standing in a lab coat. Thank you, Tequila. Somebody standing in a lab coat laughing madly, and he looked exactly like I'm dressed right now. And he went, ha 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 ha.
Whoa, no.
I am Dr. Acula. See the name tag? Dr. Acula? Oh, there's no more name tag. It fell out. No, not Dracula. Dr. Acula. I went to college, and I got a PhD in chemistry. And then I went crazy, because PhDs in chemistry are really hard. And when you meet PhDs, when you meet your science professors in college, some of them are going to seem sort of weird. I don't know. They spend all their time working with chemicals, maybe. I don't know. But he said, I went insane, and I was kicked off of the faculty of the University of Illinois, so I set up shop in this mansion, and I trapped children here, and I will not let you go unless you can draw a Lewis dot structure. I said, thank God I had such a good chemistry teacher in high school, because I'm really good at Lewis dot structures. Are you guys? Are you guys?
Yeah.
All right, so you're going to draw the first assignment he gave me. He said, I noticed you had a flare there, and I noticed it was magnesium, and I thought I detected a faint whiff of magnesium oxide. Draw, Brian Darger. I don't know how he knew my name. That was really weird. But he said, draw, Brian Darger, the Lewis dot structure for magnesium and oxygen when they combine, because that's what you just saw happen. So I want you guys to draw an atom of magnesium, and you guys brought your periodic